Ethers and epoxides have two sets of names like other kinds of compounds we've talked about. The common names and the IUPAC systematic names. First, let's take a quick look at some common names. One of the good things about common names is you can tell pretty much right away exactly what that compound looks like. N-butyl ethyl ether has two alkyl groups attached to oxygen. One is the N-butyl group. The dots show us where the 4 carbons are. And the other is the ethyl group, 2 carbons. The alkyl groups are named in alphabetical order. So we say butyl before ethyl. And notice that each alkyl name is its own word. So this is a 3-word name, N-butyl ethyl ether. And it's referred to as unsymmetrical because the 2 alkyl groups are different. Here's a symmetrical ether, diethyl ether. The same 2 groups are attached to oxygen, so we'll say diethyl. Here's another one, diisopropyl ether. These fall in a category that we call symmetrical ether because the 2 alkyl groups attached to oxygen are the same. A few cyclic ethers have their own common names. The 5-membered ring, which has 4 carbons in it, is called tetrahydrofuran, and it's very common because it's used as a solvent. And there's one more special one, ethylene oxide. Like ethylene glycol, this is not an ethylene, but it's made from ethylene, used very widely industrially. The IUPAC systematic nomenclature uses the same 8 steps we've mentioned before, and I put them up on the screen just so you can refer to them if you wish. I won't go over them again now, but you can take a screenshot of these to refer to later. So let's apply these rules to a few ethers just to get practice. The first thing I have to tell you is something surprising. Although these are ethers with a special functional group, the IUPAC system does not recognize ethers as a functional group. So these ethers are named as derivatives of alkanes. So our first step is to find the highest priority functional group. There is none. Our second step is to find the longest chain. 1, 2, 3 carbons. So this is a propane. There are 2 substituents, and we need to place them in alphabetical order. Methoxy comes before methyl. Then we need to number the chain. We'll start from the end. That gets us to a substituent quickest as we number it. So this would be 1-methoxy, 2-methylpropane. Let's look at another one. Take a look at this guy. We'll find the longest carbon chain. I'll put dots at each carbon atom. When we count those carbons, we see that this is an octane. It has 2 ethoxy groups and 1 fluoro group. Now E comes before F, so we'll write the fluoro next to the octane. We'll leave a space for the number, and we'll write diethoxy. There are 2 ethoxy groups. We'll number the chain from the end that's closest to a substituent, which makes this 3-fluoro and 4,4-diethoxy. And there you have it. Let's look at a cyclic compound. Again, we'll remember that the ether is named as a substituent. So this is simply that's stuck onto a cyclopentene. And remember, we don't need a number to tell us where the double bond is because it's understood to be at the 1,2 position. And we'll number starting where the substituent is. So we'll call this 1, 2, 3, 4, 5. And because this is the isopropoxy substituent, we'll put that name in front of cyclopentene and then use the number to say where it is. It's on the 1 carbon. So the approach used by the IUPAC system names these guys as another compound, and the alkoxy group is always a substituent. And finally, because they're special, we'll talk about the naming for epoxides just briefly. The smallest epoxide is ethylene oxide, using the common names, and the IUPAC name for this is oxirane. Larger epoxides are named, calling them epoxides, and numbering where the epoxide ring comes along the chain. So again, we'll find the longest carbon chain. This is a 6-carbon chain, so I'll call it hexane. Put epoxy as the substituent, and number the 2 carbons where the oxygen appears. So this will be 2,3 epoxyhexane. There you have it. Simply name ethers and epoxides as substituents.